All right. Hey kids, it's it's a little late, but anyway, let's work on this. This is the study guide for Wilson High School algebra final exam. Okay, so we're working on PEMDAS, which is parentheses, exponents, multiply, divide, add, and subtract. Multiply and divide, we just go left to right. It could be divide first or multiply first, depends what you see. So let's work on this problem. You might want to start by distributing the 6 times m and 6 times 1. And then you might want to get the variable to one side. I recommend moving the smaller coefficient. So you might want to subtract 2m to both sides. That's called subtraction property of equality. We end up with 38 is equal to 4m plus 6. And then from here you can minus 6 to both sides. Once again, that's subtraction property of equality. And you're left with 4m is equal to 32. So, take 32, you divide by 4, and m is 8. Okay, so let's move on to the next problem. Working on this one. So, you should distribute the 4 times 3x and 4 times negative 2. So that's 9x plus 12x minus 8 is equal to, you might want to, what is that called? Combine multiplications where you have 21 minus 3. So that's like 18. And you have 18 minus 5x. Now what? Maybe clean up on the left a little bit. You have 9x and 12x. You can combine them. That's 21x. And you have to minus 8, and that's equal to 18 minus 5x. So you might notice that you have x's on both sides, so you want to combine them. I recommend you move the smaller coefficient and do the opposite, so you're going to add 5x to both sides. Then you have 26x minus 8 is equal to 18. That's gone. And then let's get the x by itself. We can start by adding 8 to both sides, so we add 8 to both sides. So 26x is equal to 18 plus 8, 26. So you divide both sides by 26, and that's equal to. There you go. I think that was good. Let's move on to number 2. So in statistics, we have 3 ways of describing average. There's a mean, the median, and the mode. The mean is one way of describing the average. And to get the mean, we add up all the numbers, and then we divide by the amount of numbers. So in this example, where Bailey volunteered 28, 32, and 27 hours for each of the last 3 semesters, how many hours must he volunteer this semester in order to have an average of 30 hours per semester? So we recommend our students do community service because it's good for them and it's good for the community and it's a school good. It gives them a better chance of getting sent to the rockstar colleges. So let's get Bailey an average of 30 hours per semester. So we already know the first 3 semesters. We don't know the 4th semester. So what does the 4th semester have to be for to get an average of 30 per semester? So let's check out the average. So it's 28 plus 32 plus 27 plus x, that's the 4th semester, divided by 4 because there's 4 pieces of data. And that has to be equal to 30. Because if it's 30, then Bailey's a rock star. So we need to solve for this. I think maybe we should add up all these numbers, like 28 plus 32 plus 27, and that comes out to be like, is that 87? I think that might be 87. Check. Yep, 87. Alright, so we have 87 plus x divided by 4, that's equal to 30. So our goal is to solve for the x. We want to get rid of this divide by 4. So multiply both sides by 4. We have 4 over 4, that reduces down to 1. And we have 87 plus x is equal to 120. So to solve for x, we can take 120 and we minus 87 to both sides. So minus 87 here and here. So that leaves x, and x is 33. So 33 hours in the 4th semester, and Bailey will have an average of 30 hours per semester. A very nice thing. Alright, let's move on to number 3. So here's number 3. It's a literal equation. So a literal equation is an equation with lots of letters, like a formula, like distance equal to rate times pi. So let's solve this. This is a volume that equates pressure and volume and temperature. We're trying to solve for m. So to get n by itself, it's being multiplied by RT. So the inverse of multiplied by RT is divided by RT. You can see R over R, and T over T reduces down to 1. And that just leaves 1n. And 1n is equal to PB divided by RT. There you go. So on the second problem, this is an equation that ties in volumes with the height and the perimeter of a cylinder. Probably one of these guys over here. This might be an incorrect form, but whatever. We're solving for B here. Alright, so to solve for B, we have to undo that pH business. So minus pH to both sides. So pH over minus pH, that's 0. So we just have 2B on this side, and on the other side we have B minus pH. And then to solve for B, we just have to divide B by 2. And there's our equation. B is equal to B minus pH divided by 2. Here's your base. This might be a formula for surface area instead of volume. Whatever, that's not material. Alright, let's try number 4. And then number 4, solving absolute value expressions. So if something is in the absolute value is equal to 12, then whatever inside the absolute value sign, it could be 12 or it could be negative 12. You don't really know, but you know that when you take the absolute value of something, it's guaranteed to be a positive outcome. So we're going to solve for x, and we know that the absolute value of x plus 5 times 2 minus 8 is equal to 10. So we're going to solve for x by getting rid of that negative 8. So we're going to add 8 to both sides. And then you have 2 times the absolute value of x plus 5 is equal to 18. Now you might be tempted to distribute that 2, and it will probably work, but our recommendation is you don't do it. Because if that's a negative number, then it's going to throw off everything. It's going to make everything wrong. It's best that you don't distribute the 2. But you can get rid of it by dividing both sides by 2, because it will be multiplied. So 2 over 2 is 1, and 18 divided by 2 is 9. So you have the absolute value of x plus 5 is equal to 9. So now you can make 2 equations. One is normal, and the other one is weird. So the normal one would be whatever is inside, which would be x plus 5, that's equal to 9. And then the weird one is x plus 5 is equal to negative 9. This one is positive, one is negative. So if you minus 4 to both sides, x is equal to 5. And when you minus 5 to both sides, then x is equal to negative 14. So 2 values of x that would make this equation true. One is 5, the other one negative 14. Alright, the final problem. Well, number 5. Solving inequalities. So the thing with solving inequality is that it's just like solving regular equations, except that when you multiply, divide by a negative number, the direction of inequality is going to change, it's going to switch. Our example didn't really set up for that, but just so you know, on the test, if you multiply, divide by a negative number, it's going to change on you. So for this one, we might want to start by adding 2 to both sides, and 4a is greater than or equal to 8. Divide both sides by 4, a is greater than or equal to 2. So this is 0, and this is 2. It's all numbers, that's to the right of 2, including the 2. So there's the graph on the one variable, not a number line. And then for this side, you might want to add 2 to both sides. So if you add 2 to both sides, you have 3a is less than or equal to negative 6. And then divide 3 by 3, and a is less than or equal to negative 2. Notice that direction did not change because we divide by a positive 3. I'm aware that 6 is negative, but we divide by a positive number, so inequality is unchanged. Anyway, if this is 0, this is negative 2, then it's all numbers to the left of negative 2, including the negative 2. Okay, let's move on to, what is that? Number 6. Number 6. Alright, here we go. Adding polynomials. Well, what's the deal with adding polynomials? What is the deal with adding polynomials? It's like combining like terms. Alright, good. So we're adding f of x to g of x. There's f of x, g of x. So f of x is p squared minus 6p minus 1. And we're adding it to g of x. And g of x is p squared plus 2p plus 3. So we're just combining like terms right now. So p squared and p squared, these are like terms, 1p squared, another p squared, that's 2p squared, and then we have negative 6p, positive 2p, combined like terms, minus 4p, and we have a negative 1 added to a positive 3, that's a positive 2. So combining like terms, adding polynomials, pretty simple stuff. Okay, this one, I don't know how simple this one is. It's finding the inverse of a function. So the inverse is of the x and the y change places, the domain and the range change places. So to find the inverse of a function, you first solve for the x, and then you switch the x with the y, and then the new y, that's your y inverse. We say y inverse, but we really write them as y to the negative 1 power. But we don't say that, we say y inverse. And it doesn't mean the reciprocal, it just means the inverse. Two different meanings. Anyway, we're going to find the inverse of this function over here. So I'm going to start by writing f of x is y, because it's easier to write as y. So y is equal to 1 over 3x plus 11. Alright, I'm going to solve for x. So I'm going to get rid of that 11. I'm going to minus 11 to both sides. 1 minus 11 is equal to 1 over 3x. And then I want to get the x by itself, so I'm not interested in 1/3, I want to get rid of it, so the inverse of 1/3 is 3, so multiply everything by 3. So multiply everything by 3. 3 times that's just going to be 3 over 3, or 1, or 1x. 3 times negative 11, that's going to be negative 33. And 3 times y, that's going to be 3y. So, we did it. Well, I did it. X is equal to 3y minus 33. And I think that took care of step 1. So the second step is to switch the x and the y. So now instead of x is y is equal to 3x minus 33. And then that is your inverse function. So we have y inverse is equal to 3x minus 33. So this is the inverse of these. They are inverses of each other. The inverses. Alright. And then scatter plots. So scatter plots are just data points. Sometimes the correlations are strong, sometimes it's weak, sometimes it's positive, it goes up. Sometimes it's negative, it goes down. Just like if we can pretty much predict that the more time that you study, your grade is going to increase, something like that. Except that the data never fits the line exactly. Sometimes this guy's going to be a little bit too much over here. This guy over here is a little bit too low, and this guy is a little bit too much, and this guy is a little bit too low, and this guy is right on, this person's right on. So the data, it falls around the line, but never really exactly right on. It's very rare that it is right on. And if it is, then we have a very strong correlation, then it has very strong predictability. Okay, so in this example, it says Frank is grounded, so he's busted for doing some naughty stuff, and his parents are like, oh, you gotta stay home. Okay, but he can shorten his punishment by doing chores, so he can wash dishes, take out the trash, whatever, and maybe that will lessen his punishment. Okay, so let x be a number of chores he has done, and y be the number of days left in his punishment. Does this fit the scatter plot? Why or why not? So these are the number of chores that he's done, and these are days that he has left in his punishment. So like this is, he did one chore, he has 2 days left, and this guy is like, he did, I don't know, 9 chores, and he has like 12 days left. Well, this actually doesn't make any sense, because it really should be something like this. Like the more chores that he does, the lower his punishment. The less chores he has, the more days in his punishment. So it wouldn't be going up, it should be going down. It should have a negative correlation. Not up. So does it fit the data? No, it does not. Why or why not? Because it should have a negative correlation, like this type of a pattern, that it actually goes up, and that's a positive. And of course, the 2 has the negative. The more chores you do, the less days that you are punished, not more days. And you don't have to negotiate with your parents, because it's all crazy. So this graph is incorrect. This graph would be like, the more time you study, the better your grades are. So, are you studying right now? It's late. You should be sleeping. Alright, let's move on. Number 9, piecewise functions. So piecewise functions are like the functions change depends on the domain. You have different rules. If you have a kid, if you've grown up, your rules are different. So you can see here's rule number 1 here. This rule looks like it's just y is equal to 1. It's just flat like that, it's always 1. And then this rule over here, it looks like it's y is equal to, well, the slope, you see it's up 2 to the right. So the slope is 1x, and then the y-intercept is like 0, so it's that rule. So when you use this rule, when you use this rule, it looks like the change right over here when x is equal to like -2. So you can see from negative infinity to -2, you use this rule. And then when x is -2, it looks like a change to this rule. Then it looks like the graph here, this one looks like it's empty, and this one looks like it's like filled in. So that means when the time the x is -2, you actually roll with the top rule. Anyway, let's write the rules already. So we know that the rule is equal to 1 when x is less than or equal to 0. And then the rules is 1x plus 0 when x is greater. Oh, I screwed it up. Not 0. Not 0. When does it change? It's good until -2, including -2. And then when x is greater than -2, it becomes this rule. So that's the top rule, there is a bottom rule. So this would be like, when x is like -5, -6, -10. And this one would be like when x is like 3, 4, 5, 0, 8. So the rules change, and then the domain change. Alright, so how we going? Let's do one more, and then you can take a break. So we'll do like 10 each. Alright, so we'll do this one, and then we'll call it, we'll take a little break, we'll come back to 11. Okay, so identifying arithmetic sequences. An arithmetic sequence has a common difference. So if you add the same numbers to get the next numbers, then it's arithmetic sequence. Or if you subtract the same numbers to get the next numbers, then it's also an arithmetic sequence. So which of these is an arithmetic sequence? Is it this one? Well, it looks like it looks like to get to the next number you have to multiply by 5. So there is a common multiplier, it's 5. But does it have a common difference? Are we adding the same number? Then we have the same. And then this one, it looks like it's being multiplied by -1. So there's a common multiplier, but there's no common difference, so also no. And then this one looks like there is a common difference because it looks like they're subtracting 2. So yes, this is an arithmetic sequence. Alright. Then this one looks like it's divided by 4 to get to the next term, multiplied by 1/4. So of course that's not. So this, and these, they're all geometric sequence. But they're not arithmetic sequence, are they? Okay. Anyway, let's take a little break. Alright, we've had 10 problems, so we'll come back and we'll do another 10. Alright, thank you.